Hey guys, Mr. Backerberg here. In this video we're going to look at the zero factor, or some people call it the zero product, property. So the zero factor or zero product property says that a product of real numbers is equal to zero if and only if at least one of those factors in the product is zero itself. So we're going to look at using that zero factor property in terms of solving an equation. So we've got the equation 6x cubed equals 11x squared plus 10x, and we're trying to solve for x. The first thing I want to do is get all of my variables over to one side. So I'm going to subtract the 11x squared over, and I'm also going to subtract the 10x over all at the same time. So when we do that, we're going to get 6x cubed minus 11x squared minus 10x is equal to 0. Now looking at solving the left-hand side, there's a few strategies that we can use. I see that we have all of these x's in here, so I'm going to look at taking out a GCF of x. So I'm factoring an x out. So that's going to leave us with 6x squared minus 11x minus 10. And all of that is still equal to 0. Now we can actually do more factoring with what's inside of our parentheses here. So we've got x times, we're going to break this up into a couple sets of parentheses. So we're unfoiling this. In order to get 6x squared, to multiply to that, we're going to need a 2x and a 3x. Now we need numbers to multiply to negative 10, but we have to be careful with these 2x and the 3x in here to make sure that our numbers add up to negative 11. So what we're actually going to end up with is 2x minus 5 and 3x plus 2. Now, this whole thing is set equal to 0. So what our zero factor property said is if this is going to multiply to equal to 0, then one of these factors has to equal to 0. So what we can do is take each of our factors and individually set them equal to 0 so that we can do some solving. So I start by taking the x and setting it equal to 0. Then I take the 2x minus 5 and set it equal to 0. And the 3x plus 2, set that one equal to 0. Now the first one, we've already got x alone, so there's nothing else that we need to do there. So that one's just a solution. On the second one, I'm going to add the 5 over to the other side, so I get 2x equals 5. And then I'll have to divide the 2 over, so I'm going to get x equals 5 halves. So that's a solution. And with this last one, I'm going to have to subtract the 2 over, so I'll get 3x equals negative 2. And then if I divide by the 3, I'm going to get x equals negative 2/3. So there's another solution to this equation. We're going to look at another example of solving an equation, but we're going to solve it using two different methods. So we've got the equation x squared equals 10 minus 4x. I'm going to get everything on one side by subtracting the 10 and adding the 4x. And I'm going to put this in power descending order. So we're going to get x squared plus 4x minus 10 equals 0. Now this one doesn't actually factor out. So one other option we've got is using the quadratic formula. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Before we get too far into things, I'm going to actually do my discriminant first to make sure that this is actually solvable. Remember, the discriminant is the stuff underneath the radical, b squared minus 4ac. If we look at our equation, the a value is the number in front of the x squared, so that's our 1. The b value is the number in front of the plane x, and the c value is the constant on the end. So if I do b squared minus 4ac, I'm going to do 4 squared minus 4 times 1 times negative 10. If we simplify all that down, we're going to get 56. We got a positive answer, so that means there's going to be two solutions to our equation. So I'm going to fill in the rest of what we've got. So negative b is negative 4 plus or minus the square root of that discriminant, so the 56, all over 2 times a, so 2 times 1 is 2. Now there are two actual solutions in here because of the plus and the minus, so we can separate that out if we want to. Now depending on the problem that you're working with, this might be satisfactory as far as an answer. If it asks you for an exact answer, you don't want to get any decimal approximations. But if it does ask you for a decimal, then it's time to fire up our calculator. So for the first one, we're going to take -4 plus the square root of 56, and we have to divide that answer by 2. So we get 1.742 approximately if we were to chop off some of those decimals. Then for the other one, we'll have to go -4 minus the square root of 56, and we'll divide that answer by 2 as well. So there we get -5.742 approximately if we're chopping off some of those decimals. So that's algebraically solving, but we can solve this equation another way. We can solve it graphically as well. So in order to do that, I'm going to hit my y equals button. I'm going to type in the equation where we got everything on one side. So that was x squared plus 4x minus 10. And we're going to graph that out. Now, when we wrote that out, that was equal to 0. So if we're looking for zeros, another name for that is an x-intercept. So we're looking for the places where our graph crosses through the x-axis. So what I'm going to do is hit my second and then my trace button. I want to find an x-intercept, which we said was called a 0, so that's option number 2. We have to do a left-bound point, so I'm going to start with the x-intercept on the far left-hand side. Left-bound means we arrow left of that, hit enter. Right-bound means we arrow right of that x-intercept, hit enter. We can take a guess, but we don't need to. We can just hit enter one more time. And we get that -5.742 again. So that was one of the answers that we got. But we need to find that other one, so I'm going to hit my second trace again, and we're finding another 0. This time I'm going to arrow over by my other x-intercept. Left-bound means we need to hit left a few times, so we're on the left-hand side of it. Right-bound means we need to arrow to the right past it, enter, enter, and there's that other solution that we came up with algebraically before. That's going to be it for this video. Thanks for watching.